Most athletes that I speak with anyway are pretty near broke, and they go, I don't have much. And I'm like, well, just go buy a carton of milk and you're probably going to get more nutrition out of that than you will out of some BCAAs.
So in today's edition of Fueling Greatness, I interviewed Professor Stuart Phillips from McMaster University in Canada. We got into protein, its impact on training adaptations.
You don't rehydrate, you don't refuel, you're smashed the next day. But protein is something over months and years, it becomes a bigger deal for sure.
We talked about all sorts of things as it relates to protein and its impact on health and performance.
You've worked with athletes enough to know this. As soon as protein becomes the major focus, then it begins to push out other macros. And the one that usually suffers is carbohydrate. And carbohydrates fuel the type of performance that most elite level athletes are going to engage in.
Professor Stuart Phillips, I can't believe it's been so long since we last had a conversation. And it was about protein, of course. Listen, not everyone will know who you are. Lots of people do. But I like to start these podcast discussions with just a little bit of intro. So tell us who you are and what you're up to.
Sure. Well, first, thanks for having me on Fueling Greatness. It's awesome to be here. I know it's new and pleasure to be on the show again. I think it's been years since we've chatted. So
it's been, I don't know, you've done maybe 5 pods with me before, either on your own or with the late great Kev, of course.
Yeah, of course.
In fact, we can dedicate this conversation to him, of course.
I'd love that. Yeah, that'd be great.
We met a few times, actually. You came and lectured for us many years ago. I mean, we already had a bit of a...
At least 9 years ago, maybe.
No, don't date it.
It's true.
Don't date it. Yeah. Dear, oh dear. Well, life is progressing, as is the research on the topic that I wanted to get into today about protein.
Yeah.
But since this is Fueling Greatness, Stu, this isn't for anyone. This is for people who are athletes, either super recreationally active people who hit the gym all the time, that sort of thing, all the way up to Olympians. So that's who we're going to talk about.
Sure.
But before we do that, why don't you give us the overview then of Stu Phillips as the academic, the researcher, etc.
Yeah, so Stuart Phillips, I'm a professor here in the Department of Kinesiology at McMaster University. Been here for 27 years now, so it's a good run. Cross-appointed to the School of Medicine. I am a Canada Research Chair. Our primary interest is really skeletal muscle. That's the tissue in the middle. And we were interested in its preservation with dieting, fasting, something like that. Or its gain with resistance exercise, or the prevention of its loss with aging. So really around skeletal muscle, and then the interaction between that and all kinds of nutritional supplements as well. So it's incorporates a lot of things, but it's a department of kinesiology, so exercise is the primary stimulus for sure.
How did you get into this area though? Because, protein is, I mean, it's a biggie when it comes to this particular field, sports nutrition, sports science. There's lots of areas within that field, but protein is the big boy. How did you get the top spot, so to speak?
Yeah. It's interesting. Like there's not as many people like carbohydrate. There are more people who do carbohydrate and fat than do protein. Like if I go to conferences, I can kind of probably guess who else is going to be on the program as far as protein goes. And I think I know everybody in the field. It started actually as a master's student. The first project I did was looking at protein kinetics and protein turnover, actually in women, in female endurance athletes. And then I sort of went in another direction, did more sort of muscle-oriented outcomes, a little bit more of the other nutrients, but then came back to protein for my postdoc with Bob Wolf, where Tipper and I had many great years. And really then when you talk about protein, it automatically just dovetails with muscle. So I don't know where exactly it started, but the master's was the genesis of it, and it's never really gone away. And, lots of great people along the way kind of pushed me in one direction or another. And hats off to Mark Tarnopolsky, Stephanie Atkinson, Bob Wolf, Mike Rennie, all these kind of folks, they really shaped my understanding of protein and muscle for sure.
And it's fascinating. In fact, you just said the golden word. I wish I had like sort of a red button that when I smack it, all sorts of crazy fanfare occurs. Muscle, because we're talking about athletes, people going to the gym and so on. And really what people think about is muscle. They're going to the gym to gain muscle. Yes, they're trying to lose weight and so on. But people who are really into the performance side of things, bigger, faster, stronger, muscle is such a key area there. So if we just sort of maybe simplify a few things, define a few things, why is protein important on a sort of a macro level here? Why is it important? And specifically, what's that link to muscle?
Yeah, I mean, one of the things I start out with when we start talking about protein is just to remind everybody that, the three main macronutrients, so fat, carbs, and protein, fat and carbohydrate are, 99% it's fuel, right? We need a little amount of essential fats, but the rest is fuel. We store it, we use it, muscle glycogen would be the big store for carbohydrate. Protein is, it can be fuel. It's not the greatest fuel. We can burn it. We mainly burn the carbon skeletons, but it's a substrate too. It's the building block of, muscle would be the primary tissue that everybody goes, oh, muscle. But also, everything, right? Your bone is 40% by composition protein. And so all your connective tissues that are made up of collagen are protein. Your skin is protein, your heart's protein, so, and I think the important point I make to people is that every tissue is constantly being remodeled. So it's turning over. So we're making new protein, but we're also breaking it down. And it seems odd to have the two going on at the same time, but it provides, if you like, sort of a quality control check on the composition of tissues. And muscle is no exception. And clearly when you exercise, you're hammering away and, trying to remodel and change muscle. And so protein is a substrate to do that. That's its primary purpose.
That's what I love about nutrition, being a nutritionist, is the role that nutrition can have in this remodeling process. For me, it's very much about how can the nutrition advice, recommendations, the plan, if you like, support adaptations to training? How can we support body composition goals, performance goals, recovery goals? But a lot of these things can be sort of static ideas in the head. And it's that thing that you just said about this constant turnover process, which is particularly interesting. And of course, there's different rates of turnover depending on what we're thinking about. Mm-hmm. It depends we could just keep saying it depends throughout this entire podcast, and we will get into some contextual issues because I love it, as you know.
Sure.
But this, what's happening with this protein turnover? Why is there a process of protein turnover? And then if we sort of differentiate turnover of protein for sort of basic bodily functions, health, if you like, and then move that over to the training, adaptations, and performance piece.
There's a little bit of nuance in here, and I'll try and explain it sort of as simply as possible without, going too deep into this. But when we make proteins, we string together amino acids, and, that's the primary sequence of the protein. And then what actually happens is the protein begins to fold, and those are, catalyzed not by any reaction, but actually that's just the natural tendency of the protein. So that folding response is what creates a functionally intact protein. And it's surprisingly bad. So a lot of proteins get what we call misfolded. And misfolded proteins they're non-functional. So they're targeted for degradation, almost immediate degradation. They're made and they don't fold in quite the right way, and they're just degraded. The other point is the proteins that currently exist are damaged. They might be physically damaged in muscle. They kind of get ripped apart. They might be damaged through oxidation or nitrosylation, these sorts of processes that modify the protein so it's not functioning. It's almost as if every protein has sort of got a function, and yet, it's like your engine doesn't go right. So the idea is, we're going to tear it down, And instead of like, we're going to rebuild it, we're actually going to tear the whole thing out and put a new one in. And so that's the health and sort of maintenance aspect side of things. But you could almost imagine that in an athletic population who were subjecting themselves to these enormous energy expenditures, enormous high forces and everything, that the whole turnover process becomes more rapid. And so you've really got to keep up then with this constant turnover and hopefully tip it in a direction so that there's no net accumulation of damaged proteins, if you like. So in health, we talk about that happening slowly. I think in athletes, if you didn't have enough protein, it could happen more rapidly. And you don't necessarily experience, oh, my protein stores are low. Take some time, but it will be manifest by suboptimal adaptations.
Yeah, and that's what's interesting with protein, isn't it? Because you think of carbohydrates, you think of storage within the body. You think of fat, we can see very obvious increases in fat storage, but
unfortunately, yes.
Unfortunately, damn it, yes. But protein's a whole different thing, which is interesting how that sort of came about through evolution and so on. But ultimately, you've just added something there, and there's that business of this isn't even a particularly efficient process. Is that an accurate statement, or is it a different way of looking at it?
Yeah, I think, when you look at proteins that are made, the percent of proteins that are made and actually are functional, it's not particularly efficient, but we're pretty good at sort of recycling some of those amino acids that come from the breakdown of proteins, but obviously not 100% so. And that's why we need this sort of daily infusion of these amino acids to put the blocks back into the pool so that the pool's ready to respond to the next time it gets called on to make new proteins. So, the pool's primed all of the time, but when you feed is the only time when amino acids are flooding into tissues to really sort of kickstart the process and get new proteins made for sure.
Is that why we have become, particularly in sports nutrition, sports science, more obsessed with protein, things like the dose, the timing, how we spread that out, because there is this lack of storage mechanism within the body, and therefore it really is dependent on what we do on a day-to-day basis. Is that why?
Yeah, I think that's exactly the point. There are some people who are sort of the opinion that maybe you could put some of this protein into like gut tissues or something like that and then release it later. There's actually no evidence to support that, but the theory is that there's no sort of little protein storage bag. When you ingest protein, amino acids go up in your blood, and you have to use them during that period in which they're elevated because that drives the inward push of those amino acids into tissues, and so they get used. They kind of leak out a little bit later, but not all of the essential amino acids come back, and that's really the key part of 20 amino acids, 9 we need for sure. It's sort of like, bricks in a wall. You need all 20 bricks, but the 9 bricks, that protein that you're eating, that's what it provides.
Yeah, we'll come to the protein quality issue a bit later in this discussion, because it's really important and very interesting and quite a heated debate, not between us, obviously, but some people can get really into this thing.
Very much so.
But there was one paper that I read. It's a while ago that you did the protein requirements beyond the RDA paper, but I found that particularly interesting because there is this piece about RDAs, recommended quantities, that I find particularly interesting. And this is before we get into maybe what's more relevant for athletes, but since all athletes are human beings and we're all going to get older, or we might start our careers as athletes when we're kids, there's all sorts of pieces there. But ultimately, we still need to eat enough protein for health and so on. What got you into this debate, shall we say, about RDA, and which I've heard described in different ways, not always politely. But one of them was a British physician, I think, who referred to RDAs as a ridiculous dietary arbitrary. What do you think?
Well, I think the hard part with when you say RDA, and if it stands in North America, that's the recommended dietary allowance. So first, the recommended part grates me a little bit because I don't think it should be recommended. And I definitely think you should be allowed to eat more. So, myself and several other people in the field are of the opinion, based on data, it's not just abstract, that the recommended dietary allowance is insufficient, not necessarily to sort of cover basal protein turnover. And if you're just sitting around, it's probably not too bad. But definitely for people who are habitually physically active, and so athletes, and it probably scales up to some of the more elite ones. And then as you get older as well, when you become less efficient at processing protein. So it's based on a methodology that has acknowledged problems, but it seems that we just can't move beyond this old nitrogen balance methodology into some of the newer methods and acknowledge that there are lots of observations now that show that the recommended dietary allowance just isn't sufficient, or if not sufficient, it certainly isn't optimal for adaptation, which is, where if you're going to, as you say, fuel greatness, you don't want to just be sufficient. You want to be in the optimal range of things. So I think that's where most of us push back and say, we could do better. And I use one example. It used to be that the intake for vitamin C was defined by prevention of scurvy, for example, which that everybody you need vitamin C, and then there was recognition that we could do better in terms of immune function and a few other things if we consumed more than the level of vitamin C that we needed to prevent scurvy. And so they changed the requirement, and it would be the exact sort of parallel argument for why protein should go up. And we just haven't been able to make that leap, I guess. So,
yeah, I guess also a lot of this comes down to terminology that people use. Sufficient for what, of course, but right. Sufficient, optimal, maximal. There's an interesting thing there as well, with plenty of it depends thrown in, obviously. And I do want to tease that out because the audience are, they're either athletes or very seriously into their physical training and want to optimize their outcomes through learning this stuff, but also a lot of practitioners and researchers are listening too. So it's all very interesting. Let's just go back to this thing about protein turnover, because we do have terms like muscle protein synthesis. There's muscle hypertrophy. I've had a number of guests already on, including Brad Schoenfeld was on recently. We got very much into the hypertrophy piece. I've done some research myself in this area with Tipper. We did a making sense of muscle protein synthesis paper. And that was necessary because people really don't understand that term properly. And it's very interesting. But it is this business of turnover that I find particularly interesting, particularly as it relates to the accretion of muscle mass and or factors that relate to adaptations to physical training. Could you just take us through that in a bit more detail?
Sure. I think I started with the analogy, and it's worked for years. And so if you've heard it before, you can go, oh, here he goes. He's going to talk about a brick wall and bricks going into the wall and bricks coming out. But it works pretty well. Most people can grasp it. So, the wall's made up of these 20 bricks, 20 amino acids. We need to bring in 9 of those bricks. We can make 11, but 9 are de rigueur. We need them from the outside. So that's the dietary protein that we need. And these 9 essential bricks or essential amino acids are, higher in some foods, not as high in others. And, that's a protein quality issue. And the whole idea is that, turnover implies is that both processes, so synthesis and breakdown, are happening simultaneously, and they're ongoing all the time. So they might sort of ebb and flow. When you eat and all of the essential amino acids and bricks go up, then they flood into tissues, and muscle is a great example that we know a lot about. And that triggers the process of making net new pieces of the wall. And At the same time, we're still pulling bricks out of the wall because it's not functioning that great, and we want to keep it in tip-top shape. And that's the process of turnover. But the relative rate of synthesis is higher than the rate of breakdown. And then when we don't eat for a period of time, it's sort of, and it's synthesis that really vacillates backwards and forwards to create periods where we're gaining new proteins within tissues, muscle as an example, or we're losing proteins from within those tissues. So we want to tip the balance of those processes chronically so that, usually they're pretty close, right? But we like to just, edge synthesis above breakdown if we're going to gain protein and avoid, obviously, the opposite scenario chronically, in particular, if you're an athlete, because that's suboptimal adaptation. Or if you're an older person, then it's probably year on year on year as the breakdown is, and it's me these days, so it's all good. The downward trend is, you lose muscle, you lose bone, you lose pools of protein within your body. And so, what can you do to affect that? Well, provision of protein is the one big thing, obviously, but then the exercise is the other, because it sensitizes the whole system to be able to make new proteins as well.
Yeah, and there's that relationship, isn't there, with this turnover of proteins, and in this sort of cycle of events, you're obviously having to throw protein into that mix, which is why we eat foods. But also, if we use an engine sort of car analogy, you can get all this turnover, and you can increase or decrease it by putting your foot on the gas, the accelerator. But it's not until you engage the gear things start to move, right? And then a lot of things go into play in that process, which is really interesting. But it's specifically this protein piece that we're going to focus on, and less so on the the exercise piece.
Sure.
So there's a lot of things to get into, and hopefully we'll get into the main ones here. But there's things like the amount of protein that one consumes, when you consume the protein, sort of total timing type conversation. Some pieces are more important than others as it relates to sort of your daily sort of levels of protein balance, shall we say, maintaining a positive protein balance. Timing may not be important. It might be. But then, of course, there's the training issue there, and how important is it to eat proximal, before or even during or after. Maybe the dose makes the poison, I guess, is the first conversation, or not
Sure.
The poison, the tonic. The dose makes the tonic.
The tonic, sure.
That's the one that everyone's fascinated about, right? It's like, well, how much? How much, Stu?
So big picture first, let's zoom out. So the RDA and, the audience is probably mixed, but I'm going to use kilos. And I know you guys use kilos.
It's all right.
We've got lots of, I'm sure.
We can interpret.
Our American friends. And so I'll also do the quick conversion to pounds as well. So the RDA, it sits at 0.8 grams of protein per kilogram per day. So that's about 0.3 grams per pound of body weight. Which is not a lot, right? So if somebody's 70 kilos, that's 56 grams of protein per day. And if you know anything about the amount of protein in food, you can get that pretty quickly. In my opinion, and based at least on our analyses, you need to get up to around 1.6. And so that's twice the RDA to begin to optimize all of these adaptive processes. The subtlety then comes in, how do you split that up? And there's a lot of people out there who say, oh, well, you've got one paper where you say it's as high as 2.2. And so I'm like, so we go from 0.3, which is the RDA, up to almost 0.7 grams per pound, which is where I think, you're getting the vast majority of the benefits, to some people who go to 2.2 grams per kilo. So that's an easy one, right? Because 2.2 divided by 2.2, it's 1 gram per pound. And, all the bodybuilders love that one. They're like, see, we told you that 40 years ago. And, so my point would be is from about 0.7 to 1 gram per pound. I don't think you can see a whole lot of difference. You might be squeezing a few more drops out of the cloth, but you're in there. The question then becomes is, how do we eat this across the course of the day? And, so if we skew it, like it usually is, like a small amount at breakfast, a bigger amount at lunch, and a bigger amount at the end of the day. And the more data I begin to see, I'm pretty convinced, and Don Layman talks about this as well, a good friend of mine, and the first meal of the day, the first feed after you wake up, when you break your fast, your breakfast, is pretty critical. And it's sort of almost like a patterning response. And so I like to tell people, actually, that's when you really want to focus on getting some good protein on board. But it happens to be the meal where most people don't eat a lot of protein. They're very carbohydrate centric for lots of reasons. But I think that it's a real opportunity to sort of prime the system with protein. In my opinion, then, if you distribute it evenly throughout the day, that's the best way to eat protein. But there's been a recent study, good friend of mine, Jorn Trommelen, working with Luc Van Loon, another good friend of mine. I'll just quickly add that Jorn has his PhD because I let him pass because I was his external examiner. So
he sent me his PhD. I've got it
it's
on my
awesome.
shelf.
No, it's a great
Nutrition
document.
tactics.
And if he's listening, it's not that I let him pass. He passed with flying colors. He's awesome. But I'm poking him a little bit there. But they recently did a study where they gave 100 grams of protein at one meal. It was the first meal, and it was dairy source protein. There's lots of little caveats in there. But he showed that extended the protein synthetic response for a lot longer than we ever thought that it would. And so I think a lot of people got confused when we said previously, the synthetic response kind of tops out at around 20, 30 grams, something like that. And people go, so you can only digest 20 or 30 grams. I'm like, no, two different things. You can digest a lot of protein, like Jorn showed in his study, like 100 grams of protein. What you do with it and how you use it is really key. But he showed that with this big protein dose, you could sort of extend the synthetic response, and even up to 12 hours later, it's sort of, I think he called it like the barbecue study or something, like it was like eating a big barbecue steak or something like that. But so I think that those are more subtle details that we, can maybe prescribe for athletes and serious trainers, but the amount is key first. And then I do think that first meal phenomenon, because every single study that we have is, participants arrived after an overnight fast. So it's always a first meal, and all of our data is based on this. So I'm not even sure that some of the second and third meals are, and I'm speaking about some data we have in process, even as important as that first meal. So first get the amount, 1.6 or above if you choose, and then get the good feed at that breakfast meal. And if you're going to distribute, 1.6 over 3 meals or 4, however it is, then that's about 0.5 grams of protein per kilogram per meal at each meal, something like that.
Yeah, it's interesting. If we were having this conversation, but it was about carbohydrates.
Yeah.
For some time now, we've been talking about a sort of a dosage per body weight per meal sort of conversation.
Yeah.
That's fairly recent, isn't it? In protein, they've been talking about total amounts for a very long time. This is a more recent concept.
Yeah, why? And it's the devil is always in the details. So my heart of hearts, when I talk to athletes, I say, rule number 1 is protein is get the amount, right? And they say, how should I distribute it? And I said, well, if I had, another piece of advice to give, it would be that first meal that you eat in the morning. That's important. And I would argue to distribute it evenly over the day, unless you want to eat all of it at once. That's fine. But I think the main point is that people are low at their first meal, and that's missing the real opportunity, because that's when the system is most sensitive to a protein feed, as far as we can see. And again, I'm speaking based on some data that I've seen some of the preliminary results, and it really. But Don's been telling me this for years. I give him due credit on this. He goes, "It's a first meal phenomenon, Stu," and I'm like, "I get it. You're probably right." And I think he is. So.
Yeah, I've heard him speak a number of times. He also talks about the end of the day as well, doesn't he? You start your day and end your day with a good protein dose and just stop worrying about all the other meals.
Yeah. Well, I don't know if you shouldn't worry about it, but the end of the day meal is then that, depending on who you are and where in the world you live, close to bed or sort of close to bed, it definitely, if you're in the Mediterranean region or South America, you're eating like, 10, 11 o'clock at night. And I don't know about you, that's like pretty much on my bedtime. So.
Yes, well, Grandpa.
Yes.
Some of us stay up later.
Sorry, son.
Now, you mentioned a term there, priming. Now, that is a really interesting area. The other thing you term you used there was the sensitivity of it. But what do you mean by priming? What do you mean by it's most sensitive at that time of day, for example?
Yeah, I mean, the sensitivity always refers to, at a given dose, you get this response or you get this response. So the system that gets the big, it's more sensitive. And so if you compare the breakfast response to 20 grams of protein to the lunch response, so you've already had 20 grams at breakfast and then you have it at lunch, the breakfast spike is bigger. And definitely than the dinner spike. The way you compensate for that is most people eat more protein at dinner, and so then maybe you're equally as sensitive. But I think it tends to wear off. So that's the sensitivity part. The priming is that I think if you had a small dose at breakfast, which most people do, so let's say 10 grams, and then you thought, oh, I'm going to spike it at lunch, so I'll have 30. I don't think you get the response to 30 at lunch as quite as robust as if it were your first meal of the day. So there's a priming effect of that first meal that sort of almost dampens the second meal. So let's just say if you put the distribution in the opposite direction. So 10, 30, and as opposed to 30, 10 for a breakfast and lunch meal. Dinner, because you wait some time between lunch and dinner, maybe it is, and you eat more protein. And it's the meal that takes you into, obviously, for most people anyway, sleep.
Sure. Yeah, and we'll get to the training piece because obviously that changes things depending on what time you train, how many times you train, and so on. A lot of this stuff relates to people who aren't elite athletes, of course, and there's this, people are taking research from one arena and applying it into a different arena, which is an interesting thing that we can get into. But this idea of priming is really interesting, just to stay there for a bit. So is this something that's trainable, or is it just the process of sort of an adaptive response that, if you get used to having a big bolus of protein every breakfast, after a while, there will be maybe more chronic adaptations to that? What are your thoughts?
Yeah, hard for me to say, to be honest with you. I want to say because everything from fish to birds to mammals has evolved a system to, take care of nitrogen, is that, if you keep doing it, my guess is it probably wouldn't change. But I do think that the sensitivity of tissues like muscle, for example, is enhanced after the period where you've gone the longest that you're not having protein. And that's generally like you go to sleep and you don't eat in the middle of the night, and then you wake up. It's probably similar to sort of like an insulin sensitivity issue. It's got some parallels there, but a protein sensitivity issue. I'm not sure whether you would get a sort of a phenotypic adaptation with that. In my heart of hearts, I'm always, if protein synthesis goes up and you got a robust response, you're going to get a phenotype. But it probably takes a long time, probably takes quite a lot of people to see. But if you're that kind of athlete, looking for that last little turn, of the screw, then these are the types of things that I think begin to matter.
Okay. So I'm thinking maybe then beyond this idea of, training or adapting this sort of priming effect, that there is the idea of efficiency, of course, and you've already mentioned that. What do you mean by protein efficiency? And is that something that changes or adapt? Like, do you become more efficient, if you start to eat a certain way? Is it age related? What are the factors in this?
Yeah, it's definitely age related and activity related. So, I mean, we can. We're pretty sure now that one of the underpinning reasons why older people lose muscle mass is that their sensitivity to a given dose of protein for making new muscle protein, stimulating muscle protein synthesis, is reduced. And then people go, why is that happening? And I'm like, well, it's probably something to do with age per se. So pick your favorite mechanism for cellular aging, and something's happening there. But it's also due to activity as well. And I mean, everything from earthworms to humans as it gets older does less. So, and we can make young people look like older people by making their muscles inactive. And we do that by putting a brace and creating atrophy in their leg, and it looks like an older muscle. So activity is definitely part of it. Then age would be part of it. But if you're the athlete and, so activity is not an issue, you've got that going on all the time. It could be, how much training you do, how much damage there is in the muscle, and a few other things that could affect that. But I don't know that you can train it with the eating side of the equation as much as you can probably in balancing the training variables that you have and then getting the adequate nutrition. And so, obviously fluid is number one. Fueling is number two. And you've had people on way better fueling than me, right? And then protein, not unimportant, but it's kind of a distant third in terms of the macro that you need to promote adaptation, because you're going to have to be suboptimal in protein in your practices before something shows up. You don't rehydrate, you don't refuel, you're smashed the next day. But protein is something over months and years, it becomes a bigger deal for sure.
What about people who, and there's many of these people, particularly in my world, who are obsessed with protein. They eat huge amounts of protein all day long, and it's not just animal or plant-based protein, typical plant-based protein sources. They're also taking their shakes, they're doing their protein bars, that sort of thing. Does that influence this efficiency piece? Is there an area there? What do you think?
Well, we've known for years now, decades, the more protein you eat, because nitrogen as the essential nuclide of protein is I'll use the word toxic, and everybody, I'm like, toxic? What do you mean? I'm like, well, everything has evolved a mechanism to get rid of extra nitrogen. So fish make ammonia, they excrete it. Birds make uric acid, and they excrete it. And mammals make urea, and we excrete it. So all of the systems to upregulated to get rid of protein, the more and more and more you eat. So just realize that the more you eat, the more your body is upregulating everything to dispose of excess nitrogen or excess protein. And so at a certain point, you kind of have to keep doing that. You're kind of locked into that pattern. I'm a big fan of trying to get nitrogen and protein and essential amino acids through food, because food has other nutrients that we need as well. And not that protein supplements are bad per se, but to me, the biggest thing they bring is convenience. It's not that you need this or it's more efficient, but it's definitely convenient. So, I'm not a huge proponent of, sort of going up into the 2.4, 3, and 4 gram per kilo range, mainly because we have some data on this as well. Actually, it doesn't actually promote greater adaptation. Like, there's nothing better than the types of intakes that I'm talking about. And if anything, it may actually sort of gradually point things in the downward direction because of this upregulation. So, and the only other point, and you've worked with athletes enough to know this, as soon as protein becomes the major focus, then it begins to push out other macros. And the one that usually suffers is carbohydrate. And, from a health standpoint, that may be different, but from an athletic performance standpoint, hopefully we can all agree with, not too many zealotish viewpoints that carbohydrates fuel the type of performance that most elite level athletes are going to engage in.
Yeah, some previous Feeling Greatness episodes, we got into those pieces. Like with Graham Close, we got into the food first but not food only conversation, which was really good. And with Asker, we got into that whole fueling thing. So I think the listeners.
So you had a couple of scrubs on talking about it. I get it. It's all good. Yeah.
I just pick these people off the street.
I don't know. Yeah.
I'm just winging it.
Yeah.
I'm just winging it. No, but in all seriousness, that is why I'm talking to people like you and Asker and Graham and all the others. Last week, Margot Mountjoy, we talked about Red.
Awesome. More Canadian content.
More Canadian. Well, I'm being paid by the Canadian Tourist Board.
Excellent. And I'm sorry, just say,
Well, it's all right. It's all right. I'm in Scotland. There's a special link.
It's true. It's true.
So I don't want to lose my train of thought here, but this thing about protein and whether or not somebody's over-consuming protein is interesting, because there are reasons to have high levels of protein, depending on what we're trying to do. Now, normally we're not just trying to, peak leucine thresholds. We're not just trying to maximize muscle hypertrophy. We're also trying to hit other things like the satiating benefits of protein. And one way or other, we want our athletes, our clients, our whoever, to be maybe eating more of certain kinds of foods and less of others. And that's where protein can have its uses.
Sure.
One of the pitfalls, though, that I find, particularly with the types of athletes that I work with, when they're trying to eat a lot more protein, they are going down the convenience path.
Right.
Because eating that much chicken, that much beef, that much plant-based, food-based protein sources can be a real challenge.
Yeah.
So then they really get into the sort of the more processed forms of protein, your powders and your bars. And in there, a bit like a Trojan horse, there's other things inside these things typically that they don't realize because they're not as good at reading labels or whatever. So they end up with all their carbohydrates and sugars and all that other stuff. Not that carbohydrates and sugars are different things, but you know what I mean? So that's why I'm asking you about this piece about, is there too much? What's the consequences of consuming too much? And I guess the big worry, particularly I've heard from some of my youth athletes, their parents will come and say, oh, but it's, my GP, my doctor, the family doctor said that protein's bad for you.
Right.
What's going on there? Why are people worried about excess protein? You already mentioned the toxic word, but what's going on?
Yeah, I mean, toxic from the standpoint that biological systems just want to get rid of nitrogen. Free nitrogen doesn't exist in biology. It exists as an ammonium ion, and that alters pH. And so, let's push the toxic part aside and say that the three horsemen of the protein apocalypse are: first, protein changes your blood pH and it causes your bones to be weaker. It leaches calcium from your bones. So that's categorically incorrect. And so just to set the record straight here, three nutrients matter for bone. And primary, number one and number two, are calcium and vitamin on your side of the Atlantic, D. And then protein is number three. When you've dialed in calcium and you've dialed in vitamin D, then protein is a bone supportive nutrient. The observation was you ate more protein, you excreted more excreted more calcium in your urine. And that's as a result of because you absorb more calcium from your gastrointestinal tract. So that theory, it used to be called the acid-ash hypothesis, is categorically incorrect. Number two, that's an older one. Number two would be protein, in quotation, my air quotes, causes kidney damage or failure. It's called the Brenner hypothesis. It's been around for 60 years now. And the WHO and the Institute of Medicine in North America agree that there is no relationship between dietary protein and progressive decline in kidney function with age. I'm not making that up. You read the Beyond the RDA paper, so I quote them directly there, and they agree. And so those are some pretty learned people. We've done meta-analyses on this, so have lots of other groups, and 60 years later, we're still looking for the evidence that causality that's implied is there, and we can't find it. So everybody said, well, absence of evidence isn't, and I'm like, okay, but it's been 60 years. Maybe the hypothesis isn't right, just to be clear. And so that's where we're at on that one. I think most people now are thinking there's no causality. If you have chronic kidney disease, protein restriction, probably a good idea because you're trying to preserve kidney function, but not for athletes and mere mortals. The last one is protein these days causes rises in things like IGF-1, insulin-like growth factor. It promotes cancer. It can trigger rises in mTOR activation that lead to cardiovascular disease. And, from that standpoint, there's a lot of other nutrients that I would pick on before protein as a causative agent in both of those diseases. And if you stay tuned, and if we ever get this published, we've got some data that shows that when you look at big samples, food record type data, because there's no controlled trials on this, obviously, but observational data, that there's no association between protein intake and cancer or cardiovascular disease. There's association between protein foods. So, the one that most people can put their finger on is like red meat, for example, and colon cancer. But that's not a protein question. And in fact, if you look at all of the data that's out there, plant protein, if that's, the bent, it's pretty important these days, is actually not associated with any adverse health outcomes. So it can't be protein per se, probably more the foods that contain protein. So that's generally the GP-based advice, although I think most people hang it on the kidney, causes kidney damage, kidney failure. And there's just no data. So most people now are coming around to maybe Brenner wasn't quite there.
Yeah. And, when you talk about the importance of that first dose of protein every morning, and yet everyone's eating, not everyone, but lots of people are eating their cereal-based breakfasts, or cereal, toast, those sorts of things. A lot of these things, of course, are embedded in culture. Here in the UK, it's what everyone's doing. Or up here in Scotland is porridge. It's a really interesting one, and how over time these sort of myths, continue to perpetuate, sort of law on this sort of thing. But the area that I think protein is really interesting, we'll get to how it impacts adaptations to training in the next segment. But here, protein can play a really valuable role in weight management. Weight loss, huge area. That's the reason to go see a nutritionist, for example, or a dietitian, But again, there's, we mean different things when we use the phrase weight loss. What we really want to be doing is a quality weight loss, high quality weight loss. We use phrases like body composition or recomposition and so on. It doesn't matter which way we're coming at this, protein's going to play an important role there. So why is that the case, and what do we need to know about protein in this weight loss piece, quality weight loss piece?
Yeah, I think, so my rider statement when we talk about weight loss is, in my opinion, all deference to the carbohydrate insulin hypothesis, is that I favor a thermodynamic hypothesis. So less energy in than energy out, and you lose weight. Carbs and insulin, and we can argue back and forth, but that's not the point. So the point is that the numbers we usually quote are that if you lose 10 pounds, 2.5 pounds of it, or 25%, it's lean mass. So some of which would be muscle. And, for athletes or people who are maybe worried about physique or physique competitors, that's not what they want. They would like to hang on to as much muscle as they can. So the way to push back against that muscle loss would be necessarily then to maybe increase your protein intake to try and offset that. I think the far more potent way of doing it is to be active in lifting weights, and that helps you retain muscle for sure. But ourselves and lots of other people have shown high protein diets, there's a tremendous thermic effect associated with the protein compared to carbs and fats, and that's the energy burned by digesting and assimilating and storing and using protein. It's the most satiating of all the macronutrients. It's maybe not a huge effect, but it's there. And at the same time, then it helps you hang on to lean tissue, which is really the tissue that you want to hang on to improve the quality, as you mentioned, of weight loss, which would be the loss of weight with the highest possible fat to lean ratio. So higher protein, do some weightlifting, and then things begin to shift. And maybe this recomp occurs, which, under certain conditions you can see is that you lose fat and you can gain muscle. Despite I can't be done. Athletes do it all the time. Weight division athletes, aesthetic sport athletes, they do that type of manipulation all the time. It's difficult, and it takes a lot of diligence and planning, and you need to have somebody that knows what they're doing. But it's done for sure.
Yeah, it's a team effort, that one. I mean, that's something I have to do with a lot of my athletes. And it's, like you say, it's pretty complicated. But on this quality weight loss piece, what's the relevance of timing of protein in particular? Is there anything there?
Yeah, so our thought is that, usually the rule of thumb is, you should aim for 1 to 2 pounds a week of weight loss. And, sometimes athletes are just, they need more than that. They need to make a big cut to make weight or whatever it is. And, obviously fluid loss is one of the biggest ways to do that. But maybe they're tapering into a competition and they need to be at this weight for, maybe power to weight ratio issues, or this is where the coach has said, or they have the look at this weight. And in those scenarios, then we're really talking about more rapid weight loss usually. And in that sense, then that ratio of sort of, 3 to 1 or 75 to 25 in terms of weight loss begins to shift, and you can lose more lean. So the reality is that then you probably do need to focus on timing relative to the workout for the provision of protein. Most times, people used to ask a lot about timing, like they call it the anabolic window. And the anabolic window is not as big a deal for protein as it is for carbs, for example. But if you're in a deep energy deficit and you're really trying to hang on to lean, then I think that the timing does matter, and that you should try and focus on getting your protein in close temporal proximity to your workout before, during, maybe. No, I don't know if that's such a big deal, but definitely afterwards.
Yeah. We discussed that whole anabolic window not being such an issue with Sean Arendt. That was a great chat.
Yeah. Sean's got a great paper. I think he calls it the anabolic garage door or something like that.
Yeah, the garage door of opportunity. Yes. More like a garage door of opportunity.
It's big, it's wide, and it's open for a long time.
Absolutely. Yeah. Just because I'm thinking still on the quality weight loss issue. But, big thing for people is the argument for protein, and lots of it, is its satiating abilities. How does that work? How does it satiate?
Right. Well, I'm going to say this. This is my ride or my out. This is not what I do. But I'll give you at least my take from...
Just wing it. Come on.
Yeah, no. So here's the cool part about, part of my job, right? So I get an invitation to speak at these conferences. I show up, and I'm the protein and exercise guy. Next to me is, I could have had Harvey Anderson. He's at the University of Toronto, and he's a satiety guy. I could have had Marguerite Westerterp, and she was or I could have had Rick Mattis, or I could have had somebody that is, right on Natalie Liscombe-Marsh, like all these people who are
just
protein.
used you.
It's not. This is not. So I'm trying to summarize. Me sitting there listening, like trying to understand, because they all think that it's kind of a different mechanism. So first is that the amino acids themselves could be neurotransmitters to affect central drive to eat. And that's one person's theory. The other is it changes the balance of gut hormones. So the drugs that we now have, GLP-1 agonists, are those types of hormones and compounds they go up when you consume protein. So it temporarily suppresses appetite. The drugs are way harder than protein, but let's just say that they work through similar mechanisms. And the other one is sort of a gastric distension type hypothesis that, when you eat protein, it causes gut distension and you feel full, and the thermic effect that rise in body temperature is also somehow feeding back to your brain. I don't know which theory prevails, because each of them would have their favorite, to be honest with you. But the bottom line is if you stack it sort of carbs, fat, protein, the edge goes to protein for sure.
Yeah. So what you're saying is it satiates.
Yeah, it satiates you. It makes you feel full. And I think too, I've often made this point to people, is that as a substrate, fat, when you overconsume energy and some of it is fat, you can store fat, no problem. We're ridiculously good at that. Some for the worse, right? Carbohydrate as well. Overconsumption of carbohydrate, you can turn it into fat, you can store it. Protein, it's a difficult substrate to turn into fat. So de novo lipogenesis really only happens, like new fat being made from about 2 amino acids to any great extent. The rest can act as substrates for glucose. But because of the nitrogen, it makes it energetically tough to turn it into lipid. So that probably makes it as an attractive macro, suppresses appetite, tough time turning it into fat. Why some people choose to, we said overconsume, but if you're interested in losing weight, maybe that's the macro that you could overconsume and it wouldn't be too bad.
Yeah, I think if you're gaining excess body fat due to an overconsumption of protein, you've probably got some other issues going without any doubt.
Most definitely, yeah.
So the really interesting part about protein, of course, particularly for those that are trying to fuel their greatness, their physiques, their strength, their power capacities, their ability to move and function as a really, the impressive thing that we have as animals, mammals, etc., is this ability to adapt to training stimuli. And protein plays an incredibly important part of that. Yes, the training stimulus, got into all of that with Brad.
Yeah.
That's a given. But optimizing adaptations to exercise, how does protein play a role in that? And what do we need to know?
Yeah. So I mean, coming back to this protein turnover question, and the reality is that when you provide amino acids and they are tipping the protein synthetic balance in the favor of, synthesis is exceeding breakdown, even for short periods of time. So you're taking advantage of the sensitization that exercise brings to tissues like muscle, but chances are, you could talk to Keith Barr on this, tendons are mechanically sensitive too. So is bone. So, muscle pulls on a tendon, pulls on a bone, and they become more sensitive to the nutrients that we provide them. And what you're really trying to do is to compensate for two things. First of all, during exercise, muscle shuts off making new proteins. It's an energetically expensive process. And when you're exercising, you're expending energy. So you certainly don't need to make new proteins. So we need to sort of compensate for that. If you're an endurance athlete, you're actually burning, oxidizing, not huge amounts, but enough, particularly of the branch chain amino acids that you need to replenish those stores. And at the same time, then we need to remodel and repair these damaged proteins because of misfolding, oxidation, mechanical damage, and everybody sort of focuses on muscle, but it's also connective tissue, and it's also bone. It could be other tissues as well, but the bottom line is you want to try and tip that process in a net synthetic direction. So that's really, the crux of where protein comes in and tries to promote the positive adaptation, right? I mean, I always tell athletes, I'm like, training is awesome. It's this, but all the good stuff actually happens in recovery because you get better in recovery than you were before you trained, right? And they, for a lot of them, they go, okay, I kind of get that. But then after a while, try suboptimally fueling or protein consumption, then you begin to suffer for sure.
So, well, it's not just people, when you talk about this stuff, and there's a certain amount of protein that we're trying to achieve in any single meal, for example, you're going to start talking about certain amino acids and leucine, for example. And, you hear this phrase, sort of the leucine threshold, protein synthetic responses, that sort of thing. Why is leucine important in this process?
Yeah. Leucine is not just the building block, it's the sort of trigger amino acid. I'd like to claim this as my own, but I can't. Somebody else used it on me the other day. Said it's like a player coach. It's part of the team, but it's also kind of, coaching the team as well. And it really is that it signals through a metabolic pathway that, for reasons I couldn't fully understand and tell you, is conserved all the way from yeast up to mammals. That when you provide leucine to the system, it's like it's sort of a light switch, but it's not an on-off switch. It's more like that dimmer switch. So you turn the synthetic process and the machinery on, and then everything proceeds from there. So leucine is both the building block and the trigger to get the process going. So there's been a lot of work focusing on provision of leucine up to certain levels and trying to fully turn on the synthetic process. And I'm pretty sure that's a robust conclusion. There's not much that makes me think it's another amino acid. But there's plenty of experimental paradigms where you can eat a lot of protein, even of leucine-poor proteins, and get an anabolic response because you're eating a lot of protein. So you're getting enough leucine eventually. But the best sources of leucine would be, sort of dairy proteins and animal source proteins, a few plant proteins, corn. For some, and everybody goes, why is corn high in leucine? I have no idea, but it is. So, there are a few other sources as well.
Yeah. And when we started this conversation today, one of the things that we got into is this important thing that you and Don Layman, et cetera, talk about, the importance of this, really decent quantity of protein first thing in the day. And of course, we're talking about everyone, really. That's for everyone. But specifically, moving beyond everyone to specifically athletes or people who are really serious about their training, it then does, or does it, I'm asking you, become important then to have more than just a bit of protein. There's an amount of protein, or there's something you want to get from your protein food or supplement in a certain degree of proximity to a training session, before, during, or after, for example. So for people who are looking for positive adaptations to training their muscle, for example, what do we need to know about protein intakes in that regard?
Yeah, so it's back to basics, 1.6, but the devil that's in the details. Don would, I think, have a better idea on this, but and everybody wants the leucine dose response. And my point is, we're not quite there on that one, but let's just say that somewhere around 2 to 3 grams of leucine per meal, in our opinion, depending on the food source. So you could take it as an essential amino acid mixture, then it's really bioavailable. But let's say it's in food, so about 3 grams in the meal tends to spike blood leucine concentration, and then that's triggering the intracellular switching on of these protein synthetic pathways. So you might be able to get away with less than that if you're an athlete and you're young and you're exercising, because exercise is sensitizing your muscle to the leucine effect. But I think that that's a good dose to aim for. So that would be, whey protein is always my sort of my benchmark, if you like. And it's usually 10% by composition leucine. And so, 30 grams of whey would hit that 3 gram threshold. And, hopefully everybody's not going to take that to mean I should only take 30 grams of whey, but it does the job. And we've got lots of data on that source of protein, for example. But you might have to eat a little bit more pea protein. You might have to, it depends, or maybe a bigger meal to get that sort of dose. But it's that's the kind of per meal intake that we're talking about.
And that meal before, little snack in the middle of a training session, at the end of a session, what's relevant there?
For muscle, it's after. In my opinion, there's evidence to show that it could be before, and I think it would be just as useful. Most athletes don't want something in their stomach before they work out, so that the choice is always after. The major difference, and this is where Keith Barr, again by osmosis, listening to Keith speak enough times, he would say that tendon remodels itself. It's kind of the window is open. It is short. And so he favors getting the substrates to make new tendon on before you exercise so that your tendon can make use of it, while the protein is there. For most other tissues, I think post-exercise is probably fine. Muscle for sure. Bone, probably the same as muscle, but maybe that's another sort of mechanically sensitive tendon or a connective tissue-like mechanism. But I think it's after that I'd be advocating for.
Yeah, that's interesting, isn't it? The maybe different parts of the body benefit from these things at different times. But that piece about tendons, where you're actively exercising, so the tendons that are in use are the ones that, they're in the action, they're at the front line, and of course there's an increased blood flow to that area, that sort of thing. Is that sort of the thinking? And if that is the thinking, why would it be after training for the muscle?
Yeah, I mean, the good and bad thing about tendons is, first, they last a long time, hopefully, but they're pretty poorly vascularized, right? They don't have a lot of blood flow going to them, which is why Keith is of the opinion that you need to raise all of the substrates for tendon collagen protein synthesis before you train, and then activate the tendon with the mechanical tension so that the amino acids are there so that it can make use of them in that very small period in which it is sensitive. Muscle, very well vascularized as a tissue. That's not as big a deal. And so in the sensitization per the anabolic garage door is open for a long time. And so you can perfuse muscle with blood, up to very, very high level post-exercise. So it's not as big a deal. So you can raise amino acids post-exercise, you're sensitive, and you've got good blood supply. Tendons are just not particularly well vascularized.
Yeah, no, that makes complete sense. It's more time critical. I can see that. Now, what people will be thinking at this point is, what kind of protein? So this conversation keeps coming up, and I've heard you talk about this many a time. And I guess there's different angles here. There's the plant animal-based protein conversation, but also there are different kinds of proteins. And then people will go, but you've just mentioned post-workout, so that's when I'm going to have my fast-digesting protein.
Right.
But tonight I'm going to have my slow-digesting protein before I go to sleep because it's easy to simplify things that way. So
sure.
I'll tell you what, before we talk about plant versus animal, we'll get to that piece in a second. Do you want to just get into the different types of proteins that exist within the animal protein set up and what the relevance of those different types of proteins are?
Sure. So, I think that the fast, slow protein concept is, some people caught on to this right away, but I to give you an analogy that I think people maybe understand a little bit, like high glycemic index carbohydrates, so very simple carbohydrates, get into the system quickly, rapid spike in glucose, and you use them. So that's one of the fastest proteins that we know of is whey protein. So, again, to be clear for everybody, whey protein is a small fraction of milk proteins, generally about 20% of bovine, so cow source milk protein. And the remainder, 80%, is casein, which is a slow protein. It's actually pretty unique in that when you drop milk proteins into acid, which you do every time you drink milk or eat yogurt or anything because your stomach is acidic, they clot, they coagulate, and clotted proteins they exit your stomach slowly, and they're a little bit tougher to digest, and so the amino acids appear slower. They're like low glycemic index proteins, if you like. So those are the sort of the nuances, but we can also sort of think of, if I'm having a big meal, everything slows down because the more food you put in your gut, the slower gastric emptying is. And so, the big Christmas dinner that you have is, you could be digesting that for, 8-10 hours. And everybody goes, oh, it's the tryptophan and the turkey that makes me feel sleepy. And I'm like, it could be the massive quantity of food you just ate as well. And, when you're a boa constrictor and you swallow like a big pig, you sit there for months and digest it. So we're just a microcosm of that. But things slow down the more you put in the gut, and certain proteins are slower. Most proteins are fast when we isolate them, but some behave a little bit differently.
I love the analogy there, especially of the boa constrictor there. But I think people do get that. It's very easy to focus on protein, whey, whatever. But when you're actually eating food, you're combining multiple things and putting it in the stomach. So obviously things like fats and fiber will slow gastric emptying and so on. But just to come back to this whey thing, because if we were having this conversation 10 years ago, everyone was very much obsessed with the whole IV Portman anabolic window thing. So
yes,
there was a more robust argument for consuming whey because of the speed at which you're going to get that into the muscle, so to speak.
Yeah.
But now, because this anabolic window is much, much bigger, the speed of digestion of protein is it's not as important, right? Or is it? Or
no, I agree. I don't think it's a relevant variable anymore. It used to be, I've got this whey, and then I've got this hydrolyzed whey, and then I've got this, reverse osmosis style purified hydrolyzed whey, and it gets into the bloodstream, and it's like minutes faster. And I'm like, it's irrelevant. Like, it doesn't change the adaptive response at all. But to your point, I think we're beginning to think that that's far less of an issue for sure.
Yeah. Okay. Good. Okay. All right. Maybe a bigger issue though is the type of protein, and I guess we could talk about. There are so many different types of proteins, as you know, but the big debate goes between animal and plant-based proteins. And again, if we were having this conversation 10 years ago, most people would be saying, oh, no, animal protein all the way. It's far, far superior. But things are changing in that regard, I believe. Do you want to bring us up to date on that topic? And what are your thoughts, given you're researching this area?
Yeah. It's not just me, but colleagues of mine as well. And you're spot on. Ask me 20 years ago, and it would have been the standard line. Animal-based proteins are higher quality. Quality is defined by two things. It's basically how digestible proteins are. Animal proteins are more digestible than plant proteins, primarily because plants have what we call anti-nutritional compounds dietary fiber being one, but phytates and things that interfere with, and lectins, which interfere with digestion. And the amino acid profile of animal proteins contains more essential amino acids than plants on balance. But the more work we do, and we begin to investigate these things, and particularly plant isolated proteins, so pea protein, rice protein, these sorts of things, now you've taken out the anti-nutritional components in these proteins, and you're giving them to people in quantities that the amino acid score, even though it might be lower in plants, is not really having a huge impact on what we can measure. So definitely not on rates of protein synthesis. And in the small, I'll agree, number of studies that have been done on the adaptations either. So I'm beginning to really soften my narrative on, animal is superior, et cetera, to, can you do it all on plant-based protein? And the answer is, I think, yes. You have to be quite judicious and plan your diet a little bit more carefully than you would if you're just, eating any protein that's out there. And and then a lot of people who are vegan or vegetarian say, well, I do it all the time. And I'm like, you are a special group of people who think about your food. And if you're an athlete and you're a vegan or you're vegetarian, I don't think you can be a successful vegan or vegetarian unless you're pretty judicious about how you plan your diet. So hopefully you've got either a professional or you've done a lot of your own work. But everything that we've seen to date continues to show that plant-based proteins are not inferior. If they are, it can be made up for by just a little bit of extra protein, if that's the case, to animal source proteins. So I changed my mind, and that upsets people, But I'm like, well, that's kind of how science works, New data, new opinion. That's the way it goes.
Well, that's it, isn't it? It's just as you learn more, you're able to form new perspectives based on the evidence that you have available.
Well, and I say to my students, I'm like, beware people who have never changed their mind on something, and I'm pretty dogmatic about a few things, but I don't ever ignore data, or try not to. So yeah, this is one I've really come around, and I think Luc Van Loon and a lot of other people working in this space would probably agree.
Yeah, I've spoken to them all, so that's what I've heard for the most part. So we talk about protein, and in that conversation, you talk about amino acids. You've talked about leucine. In the sports and fitness arena, I mean, you go into any, supplement store, nutrition store, you're not just going to come across protein powders. You're also going to come across branch chain amino acid supplements, that sort of thing. Yeah. And again, if we were having this conversation 10 years ago, it was a big thing to take BCAAs.
Yeah.
What are your thoughts about BCAAs? Is there a role for them? Do they work? Don't they work? What do we need to know about these?
Yeah, I mean, branch chain amino acids, of which leucine is one, isoleucine and valine are the other two, they work. But they work because leucine is the effective amino acid. So they're very chemically similar in the way they're structured. And, if people remember their biology or if they know it intimately, amino acids are transported by proteins that tend to transport similar amino acids. And so the amino acid transporter that transports leucine also transports isoleucine and valine. So if you get them together and you dose yourself with them, they effectively compete with each other for the transporters across your gut and then into your tissues where you want them, which is muscle, for example. So I'm okay with branch chains so long as everybody realizes that if you're getting enough leucine and good essential amino acids from your diet, they're largely a waste of time. Because if anything, when we've given them all together, the leucine effect is actually diminished. It's not enhanced because you've got two other amino acids competing for these transporters. So, just real food does the job. Branched chain amino acids, and everybody goes, they taste great, and I'm like, if you're getting them for taste, then I got no argument back. But I always ask athletes when they ask, what about this supplement versus this supplement? I'm like, how much money do you have in your pocket? And most athletes that I speak with anyway are pretty near broke. And they go, I don't have much. And I'm like, well, just go buy a carton of milk and you're probably going to get more nutrition out of that than you will out of, some BCAAs.
Well, yes. I mean, we could have a whole chocolate milk conversation as well.
Yeah.
It just reminds me, Stu, the BCAA thing makes me smile every time because, for all the science and whatnot, it doesn't happen now, at least not that I've seen lately, but you did see people taking pots of BCAAs into the gym, and between sets, they would be popping their BCAAs because they heard, they heard from some bro that was a good idea. But it is interesting, isn't it, how people take information and just do what they do. And this is the world that we live in now, as people get their information, not from you, not from me, sadly, which is why I'm trying to do this podcast.
Yeah.
It will be from influencers and so on. And there is this gap between science and practice, what Louise Burke refers to as scienciness. And, it's all really, really interesting. So, look, we don't have any more time. There's so many things that we could get into, but I'm going to have you sort of end this conversation with sort of an executive summary, if I can put you on the spot for that, about this topic of protein, and its sort of implications for health and performance and so on. What would your summary be?
Yeah, I mean, so protein above the RDA is where athletes want to aim. I think twice the RDA, or 1.6 grams per kilo per day, or about 0.7 grams per pound is a fine target. If you want to eat more, it's not that it's bad. I just don't think that you're squeezing much more out of the cloth beyond that. But unless you're in a scenario of a deep energy deficit where protein could play, I think, an important role in helping you retain more lean mass. There is some subtlety on timing within the day. I think that the Don Layman's spot on with the first meal phenomenon and a relatively high leucine dose, about 3 grams at that breakfast meal. I think that's the perfect. We need to pin that down exactly why that's the case. But it's definitely when your muscle appears to be most sensitive, and you get this big, good anabolic boost, and it kind of, just sets the day off right. If you like, maybe breakfast is the most important meal of the day. Outside of that, the subtleties matter a little bit less. So I don't think that there's any sort of particular advantage to plant or animal based. If you're a vegan, just be judicious about how you plan your meals, and supplements, awesome. Really try to hammer home food first, and not let supplements be a crutch for poor eating practice. You'll get a lot more out of learning how to plan your diet than you will about just sort of, mishmashing, 17 different supplements. I used to work with an athlete, a great guy. When he first showed up, he opened like a fishing tackle box. It was enormous. And it was all of his supplements. And he goes, I take this here, I take this. And yes, of course, it had branched chain amino acids. It had fat burners. And I was like, dude, what's that cost you? Yeah. So, we're beyond that now. And at least, and you've worked with some very, very good athletes. And my finding is that they're just pretty good at planning their diet. And I mean, everybody strays off of it every now and again, but the ones that dial it in and the ones that get it, they tend to have a better career longevity. They tend to, not get off and caught up in fads. And as you said, science is hard, which is why it's hard to communicate it, I think. And there's maybe a little bit of mistrust or distrust of science these days. But you can also get information from, TikTok, Instagram, and punters like us need to hopefully get the information out and, convince people that we know what we're doing, because nothing that you and I have said today is based on anything other than evidence and data. So hopefully that comes across.
Professor Stuart Phillips, thank you for joining me on Fueling Greatness. I've really enjoyed this discussion, this conversation. It's not going to be on TikTok. I don't do TikTok.
So I am on TikTok, but I'm going to tell you why. My youngest son, who is 19, told me last year, he's on TikTok all the time. And I said, I think I might get on TikTok. And he said, oh, Dad, he goes, old people ruin TikTok. And I was like, I said, are you saying I'm old? And he kind of looked at me, he goes, well, just saying, right? Which is his writer statement for, and I was like, well, so now I'm on there and I'm like ruining his social media experience, one dad post at a time, which is pretty infrequent on TikTok, I'll be honest.
Well, my boys, they're not on social media. Well, my oldest son is, but my youngest boys are too young for that. And they're not particularly excited about what I do for a career. But because this podcast is, it's on Spotify and Apple and so on, but it's also on YouTube. So now they're telling their friends that I'm a YouTuber, Stu.
A YouTuber. Yeah, that's awesome. Yeah. You could be an influencer, I think. You know what I'm saying? Yeah.
I'm not sure. We'll leave that to you. But look, Stu, thank you for your time.
My pleasure.
It's been incredible. And, down the road, we'll get you back and we'll get another update on this topic, hopefully.
Awesome. I'd love that. And thanks for the opportunity. It does mean a great deal to be able to come on and hopefully translate some of this stuff. So thank you. Appreciate it.
Well, thank you too.